So yeah, welcome everybody. Welcome to CSCI 40. I'm so excited that you're here. I do not like to put my PowerPoint in full screen mode for a couple reasons. First, because I'm going to be moving around between programs. And second, because I get such cooler pens if I leave it like this. So obviously this is how it's going to stay. Sorry if it's slightly smaller than it should be. But I totally think it's worth it. Next thing, I'm going to give you everything we do today on Canvas, so you can feel free to sit back if you would like to. You can take notes later. I'm going to give you these slides. I'm going to give you all the code that I write, and you're also going to get this recording for fun. Why not? So today's that standard day. It might be a little boring at the start. I'm sorry. But I'll talk about me a little bit, introduce myself. We'll do the syllabus stuff, try to stay awake. And then we'll actually get to learning a little bit about computer science. So that's the part I'm excited for, at least. We will get there at the end, all right? So yeah, without any further ado, let's get started. So a little bit about me. Hello, everybody. My name is Lawton Nichols. I use he, him pronouns. And I will respond to whatever you want to call me. You can call me Mr. Nichols, Dr. Nichols, Professor Nichols. But honestly, if you're feeling up to it, I would prefer it if you just call me by my first name. Please call me Lawton. I don't want your fake respect, right? I want to earn your real respect. So call me by my first name if you feel comfortable with that. A little bit about me. I went to Fresno State, not too far away, for my undergrad. Got my bachelor's there, and then I went to UC Santa Barbara, for my master's and my PhD. All three of the degrees that I have are in computer science, so hopefully I can teach you something about computer science. It's my fourth year teaching here, so I've been here for a little while now. And other than programming, I'm not a robot. I like to do human things as well. I like to dance. I'm going to go to a salsa lesson tomorrow. It'll be fun. I like to play guitar. I like to go rock climbing. Normal human stuff too. I exist outside of here. I also have the greatest cat ever. This is Lonzo. He is wonderful. This was him when he was a kitten. He's 3 now. And he still just lays on my bed all the time. So he was there when I left. It's kind of like he's always been there. So he was named after Alonzo Church. I named him after Alonzo Church, who was the PhD advisor of Alan Turing. So I'm sure you've heard of that name at least. So yeah, I dedicated my firstborn son to computer science. Look at him. So yeah, that's me. I'm excited to get to know all of you over the semester. And yeah, this is some weird post-pandemic time that we live in. Everything is odd, but we will get through it together. So thanks for putting up with me in advance. All right, let's get through the syllabus and try to remain conscious. So I'm going to go fast. It's your responsibility to read the thing, but I'll give a few highlights, at least right now. Okay, so this is an in-person class. Sometimes I teach this online, but I only have an in-person class this semester. So here's the deal. I am, for some reason in college, required to take attendance, and so I have to do that in a little bit. I'll show you how I've streamlined the process. It's going to be great. Let's see here. There is a nice loophole that I want you to take advantage of. I'm not forced to keep you in your seat if you've done all your work. After the lecture, we're going to have lab time where you can work on stuff, and if you've done all the stuff, you're free to go. How about that? All right? So you don't have to stay until the end of lab, but you do have to stay until the end of lecture. That's for sure. Okay? That's the requirement. My drop policy is pretty lenient, I think you'll agree. I'll just drop you if you miss 3 consecutive classes. Let's say that. That's like a week and a half. At that point, you have stopped coming, and so I have to drop you. I will also have to drop you if you miss the first lecture, and you're all here right now, so I don't think that's going to be a problem. So I am super lenient. If something comes up, please just tell me. Then this rule won't apply. We'll work something out, okay? Yeah, that's how class is going to work. We'll take attendance in just a second. And then the lab is going to start just when the lecture ends. Okay? There's no set time like there is in self-service. You can't time when a lecture ends. It's just going to happen. The lab starts when the lecture is over. All right? We're also going to get a little 10-minute break at the end of this lecture because this is a long class. I can't just force you to stay in your seat the whole time. And so we'll have a little break. And that'll be that. This is not an online class, so I'm going to skip that slide. And by the way, I like to run my lectures as a little discussion. So if you have something you have a question, just shout it out, raise your hand, whatever you feel like doing, and I will respond to you. It's more fun than just talking all day long. Okay? So that's that. let's talk about expectations. This is a 4-unit class, so we gotta warn you up front, I guess. This is a challenging class. Okay, I can't make it any less challenging. There's a lot of stuff that is on a list that I didn't write that I'm required to teach you. Okay. Computer science, just in general, this is probably a lot of our first computer science experience. It's a brand new way of thinking. You can't really apply knowledge that you have outside of computer science to computer science. It's brand new. It's going to make your brain feel weird for a little while. And because there's a lot that you need to learn, I have to give you a decent amount of work so that it gets ingrained in your mind. Okay, there's just no getting around it. I just want to tell you up front so that you know about it. Okay. One nice thing, depending on your ideas, is that this class has nothing to do with memorization. It's all about learning essentially critical thinking skills. So you can't really memorize anything and do well on the test. It's more about learning how to think like a computer, which is pretty nice. You'll always be able to get the answer once you learn how to do that. Okay, so that's kind of cool. At least I think so. One thing we do have here, if this class is moving way too fast for you, I do want to tell you that we have an introduction to programming class called CSCI 1. It's a GE class, and that will help prepare you for this one if you feel like you need that extra preparation. Okay, so consider taking CSCI 1, though I will be here for all of you as much as possible and make sure you do well in this class if you feel like staying. All right, I want you all to stay. Let's see, what else? This is a 4-unit class, and do we know the rule about units? So 4 units means you spend 4 hours in class each week. That's what units corresponds to hours. And then you double that, and that's supposed to be how much time you spend outside of class doing the homework, studying, and stuff like that. Okay, so expect to get close to that rule really applying for this class. Okay, so just want to make sure that is all known to you up front. But I'm really not trying to scare you away. I just want to make sure you know what you're getting into. I'm going to be here. The tutors are going to be here. We're all here to help you. I'm on Discord way too much. It's going to be okay. All right? We're going to get through this together. All right?
I'm also on Discord a lot.
Exactly. And you guys will be too. So there's that. One really nice thing about the college, if you have not heard of it before, is our technology loan program. If you need anything, this is a computer science class. If you need a laptop, if you need a better computer at home, the library will check one out to you for the semester. If you have a horrible internet connection at home and you want to watch these lecture videos that I'm recording, the library will rent out to you a hotspot router. So if you need something, check out our resources page on our Canvas modules. There's like a little form you fill out, and then you just go to the library, pick up what you need. Please take advantage of that if you need it. They'll even rent out like calculators to you if you need that for a math class. They got a lot of cool stuff. So technology loan program, the library is awesome here. And then here is the slide that I think you probably all care the most about. So let's go check out the syllabus. It is on the class's Canvas, and this is a link to it, but hopefully we found that we need to go to the course modules page first to unlock that page. Hopefully we all got there. So I'm forcing you to read all these pages, like complete all items, and then you're able to see the syllabus, and then you're able to access all the week 1 stuff. So if you see that you were locked out of something, it's because you didn't visit every page like I required you to. All right. So here's the syllabus. Let's open it like this. And please read this, but I will scroll to the part that you care most about, which is this grading section. So, all right, I will be giving you homework from your textbook. So there's going to be reading assignments. There's going to be programming assignments in the textbook as well. So that's part of your grade. And then there will also be programming assignments on the class server, which I will call labs. So there's going to be Xylabs, part of your Zybook, and then reading assignments, part of your Zybook, and then labs on the class server. Right? That will make more sense once we get into it. But the reading assignments, like going through a chapter, and I'll show you the book in a second, will be 10% of your final grade. Another 10% will be the programming assignments on the textbook's website. But really the bulk of your grade is going to be from labs on the class server. All of that is getting you ready to do labs on the class server. All right? So 25% of your grade is going to go to that. Hopefully we all saw the check-in survey in the week 1 module. 5% of your grade is going to be me every week asking you questions. So I'm just forcing you to psychoanalyze yourself. It's really cool because I'm going to ask you stuff like, what are you struggling on? How do you think you could improve? silly questions like that force you to think about how you could get better in this class. And let me know what you're struggling on too. So that is a win-win for both of us, and it's a very easy 5% of your grade. So just write a couple sentences every week and get half a letter grade's worth of credit. That's pretty nice. Exams, we will have, I guess, 3 total. So we're going to have 2 midterms. The first one will be a third of the way through the class. It's like an 18-week class. So week 6 is 1/3 of the way, first midterm. Week 12, 2/3 of the way through the class, second midterm. And then 3/3 of the way through the class is the final, of course. So each midterm is going to be 15% of your grade. Week 6 and 12, most likely the Thursdays of week 6 and 12 will be the midterms. And then the final exam will be 20% of your grade. Okay, so that's your grading breakdown. Again, the biggest thing is your labs, your programming assignments on the class server. Okay, are there any questions about this table? Because this is probably what is most interesting to you right now on the first day. We good with that? All right, so that's a grade breakdown. I like to give at least a letter grade's worth of extra credit throughout the semester, usually around exam time. So look out for that if you're interested in doing it. Take advantage of it. And then, yeah, final exam date. So hopefully I read the table. You can please confirm this with me, but I think I read the table right on our school's website. Here's when I'm pretty sure our final exam is. It's going to be the Thursday of finals week. So that's really good. That's like the latest day it could be for us. So Thursday, the 7th of December, from starting at the same time as class starts. So from 2 p.m. to 3:50. It's an hour and 50 minutes exam. Okay, so that will be in this room. That's when our final is going to be, unless I read the table wrong. I'm pretty sure. All right, that's when that's going to happen. So good. All right. We have a few slides to get through. I'm sorry. There's a lot to talk about. Another thing, let's talk about my due date policy, because it's a little weird, but I promise it's a good idea. It's worked well. So every assignment in this class, except for the check-in surveys, which we do at 5:30 on Fridays, is going to be due at 5 p.m. for you. Okay, so keep that in mind. It's not midnight. It is 5 p.m. every assignment in this class. It's going to be due then. Okay, and the reason I do that is because I don't think this is going to be your first computer science class, but you will learn soon enough how many technical issues arise as you are working on stuff. Okay, there are going to be problems, and I will be awake to help you at 5. I will also be having office hours conveniently on lab due dates around 5. So that's why that is set to that. Okay, so it really helps. I'll be there to help you. I'll be awake. All right, so that's why due dates are that, but plan on it. Okay, everything's due at 5 in this class. Though, I guess I shouldn't say that immediately. I do make some exceptions for certain students. All right, I call them my equity exceptions. And so if any of these apply to you, please contact me. Send me like a Discord message or come to me after class or something. But if any of these apply to you, I will give you an extension on your assignments, and it will be due after 5 for you. So if you work at least half time, 20 hours or more per week, then I will give you an extra 7 hours on all your assignments in this class. So it really will be due at midnight for you then. Okay, and I hope we all agree that somebody who's working at least 20 hours a week deserves that extra flexibility. Okay, so the one thing is that school doesn't count. If you're taking 20 units, that's your fault, right? Some of us have to work though, and so you'll get that extra hour, extra 7 hours if you work at least 20 hours. So that's that one. If you work at least full-time, so greater than or equal to 40 hours per week, or you do something that is the equivalent of a full-time job, like you care for a child, something like that, then I will give you an extra 15 hours on all of your assignments. So you can either stay up late or wake up early, and again, you deserve that extra time. Okay? So please let me know if any of those apply to you, and I'll get you the extension that you deserve. So that's my due date policy. Again, shout out to me if you have any questions, but I'll just keep on trucking through all this fun stuff. I'm also pretty lenient when it comes to late submissions. I will accept late textbook assignments, late labs on the class server, and late check-in surveys up to the last day of instruction. So if you miss it, you can wait a long time to do it. You're welcome. But the trade-off there is I have to take some credit away the second it's late. So here's the trade-off. If you turn something in late, the second it becomes late, I'm taking off half credit. Okay? Hopefully that seems like a fair deal to you. If you miss like the first week assignment, you can do it at the end of the semester if you need to. So that's my late submission policy. The one thing that's weird is how Canvas talks to the zyBooks, to your textbook website. It doesn't transfer late assignments very well or easily. So just remind me. Just send me a message if you ever submit a textbook assignment late, because I won't see it and it will be marked as a 0 until I manually change it to half credit. Okay, so that's the one little hang up there. Everything else I'll figure out. Like I'll apply it to check-in surveys. I'll apply it to labs automatically. All right, so that's late submissions. I'm also pretty lenient when it comes to dropping some of your lowest scoring things. I promise to drop your lowest 3 programming assignments on the class server, lowest 3 labs, I'm calling them, and your lowest 4 textbook reading assignments, your lowest 4 textbook programming assignments called Xylabs. All right, so if for a couple weeks something goes wrong, you can't get something in, it's like it never happened. All right, so you're welcome. And that's that. I think we're ready for the textbook now. So our textbook is given to us. It's a virtual textbook. It's online on a website called zyBooks, and it's super cool. It's virtual. It's interactive. You click things. You watch little animations. It is hands down the best textbook I've ever seen for this class. Everybody loves it. So yeah, so I'm going to give you stuff from this textbook. I'm going to give you reading assignments. You're going to interact with the chapters, and that's going to count as your reading. And then also some programming assignments, which they like to call Xylabs. You do have to buy the textbook, all right? I promise it's worth it. It is like gold. So let's go and talk about that. Dun, dun, dun. So I guess you can click this link, but it's not very useful. It just talks a little bit about it. It's telling you what I'm telling you here. To buy it, you can either buy it from the website itself, from zyBooks, or you can buy it from the bookstore. I don't know. They should be the same price, but one might be like easier to return if you drop the class or something. So just check the fine print. I can't tell you which is better, but they'll both give you the same book. And to get it or access it, once you got a code from the library or from the bookstore, you just go to one of the zyBooks assignments, like this one or this one, like this one, for example, Chapter 1, Chapter 2. And you'll click this link at the bottom if it ever feels like loading. Oh, did it not? There it goes. Load Chapter 1, blah, 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 in a new window. This will open up the zyBooks website, log you in with your Canvas login somehow, and it'll ask you right here to buy the book or enter in your code. Okay? And once you've done that, it will take you to like the first chapter, the first part of this assignment. And so like here's a little animation. It's so cool. And it's really nice, I promise. Okay, so you can drag and drop stuff, but that's your textbook in a nutshell. So just click a link, one of the assignment links to access it. Okay, I did put every assignment up, like they're all here at the bottom. So if you have no life and you'd like to read early, go for it. It can only help you. Right, they're all down here. Let's see here. Dun, dun, dun. I do want to encourage you to start early. This is not one of the classes where you could wait until the last minute to do things and expect to get a good grade. You will find that out very quickly if you do work like that right now. So I do want to just warn you, you should start early, definitely, especially for these first 3 reading assignments. There's a lot to read. I'm front-loading your work, and I think you'll appreciate that towards the end when you don't have a lot to read and you're worrying about finals and other classes. I'm going to give you a decent amount of reading at the start of the class instead. Okay, got to do it sometime. So that is the textbook. Any questions about that? Did we have any trouble getting it? Have we tried? All right, so that's zyBooks. Next is Discord. I hope we were all able to get on the Discord. I'll show you how if you haven't yet. Clicky click. So this is going to be how you're going to interact with your peers and hopefully with me as well. I'll try and convince you of it. But let's see if it ever wants to load. Got a lot of things open right now. Of course, there's updates. So give it a second and I'll show it to you. We're moving at the speed of JavaScript right now. Dun, dun, dun. The suspense, I know. But once you click the invite link on our Canvas modules, it will give you access to our class server. It's this one. And At the start, you only have these 2 channels up top. To gain access to the other ones, go to the Welcome channel, scroll up. First, click the 100 emoji to add the student role, and then you'll click the cat emoji to add the CSCI 40 channel. You can add your pronouns, and I've also made this guide to tell you how you can type and have it like highlight your code and stuff on Discord. But that'll give you access to a lot of these channels down here. The one that you're probably going to want to hang out in is the CSCI 40 channel. So here's discussions from the previous semester. But we will fill this up with our own new stuff this semester. So yeah, this is where all your peers are going to be. This is where I'll hang out, and the tutors will hang out here too. I highly, highly encourage you to ask questions publicly here. So like when it's 3 a.m. and you're stuck on something, your peers can help you while I'm asleep, okay? I do want you to use your judgment, though. So the one thing I don't want you asking publicly on Discord is questions where you give like all of the answer away. You type hundreds of lines of code and you show it to everybody, or you give an entire question's answer, or at least your current work so far on it away. That is more of a private question meant for just me, because I don't want to give everybody the answer, right? So please just use your best judgment. You can post bits and pieces of answers. That's totally fine, and get responses from your peers on those. But the second you feel like sending a lot of things, and you feel the need to send a lot of stuff that would give something away, that's when you should be sending me a direct message or like a tutor, okay? So you can always privately ask me stuff, and that's what I want you to do for those kinds of things. You just click my name, click message. I can't message myself, so that's not an option, but it will appear as an option for you. And yeah, that's our Discord. Hopefully you find that as a nice space. I do also want to encourage you to use Discord to contact me if you have a question about anything ever, instead of email, instead of Canvas messages, because look, I have a message from a student right now. Do you see that notification and how easy it is for me to see that notification? I think you can imagine how disgusting my email inbox looks as a professor. I might not see what you're asking. I can totally see you here, okay? So highly, highly encourage you to contact me this way, and that's Discord. Next, we have office hours for getting help. So I'm going to have office hours both in person and on Zoom at the same time. I'll have some after this class today if you have any extra questions. But you can follow me to my office. But here's my office hours info right here. So the green rectangles are when I'm going to try to have my office hours. These might change. Like I might be invited to meetings throughout the semester. Just look here and I'll tell you if they change too. But here's when I want to have my office hours. I'll have some after today, right after class. This is my office. It's upstairs in this building. I'll also be on Zoom at the same time. So these 3 are in person. My Friday office hours will be, look how it's very close to 5 p.m. Will be on Zoom only. Okay? The rest of these will be in person as well as on Zoom. So just click the Zoom link, office hours Zoom link here, if you want to join it that way, and I can get you the help that you need. So that's that. Again, the schedule might change, and I'll update you if it does. But that, I think, is what I want to tell you about there. So please come to office hours. They are for you. I don't want to just sit there. I'd rather interact with people and humans. Along those lines, I do want to say something, because this is a weird class where like sometimes you come across a problem that like the textbook isn't going to tell you exactly how to solve it. You will be stuck on something, I promise. We all get there. So you're going to get stuck on something, and I really want you to ask for help, right? What's the line that I use every semester? There is no virtue in staring at your screen for 4 hours, working on the same thing and being stuck. I did that when I was an undergrad. It sucked. It was horrible. I would have much rather have gotten help, but I was too proud. No, don't be like me. Please ask for help. Let's set a time limit. Let's do this. So let's say if you have been stuck for like 30 minutes on a problem, and you have no clue where to go from there. Like you've been stuck at the same place for 30 minutes. Once that 30-minute timer goes off in your brain or whatever, then you should ask for help. Come to office hours. Send me a Discord message. Send your peers a Discord message. Go to the tutorial center. You got a bunch of options, but that's when you should start asking for help, okay? Let's set 30 minutes as our time, right? Because I'm getting paid, right, to help get you over whatever that current problem is, and so that you could get stuck for the next 30 minutes on something else, okay? That's what I want the class to be like for you, okay? I don't want you to just be waiting and trying to think of the right answer on your own, because sometimes it just won't come. There's something missing, and I can fill in that gap, all right? Or the tutors can. So that's just something I want you to keep in mind. Please ask for help when you need it. I want to make sure you get the help that you need. Though, if you're stuck for 29 minutes and you have a flash of genius, and that keeps happening to you, that's how I'm planning the class, all right? That's exactly what should be the case, okay? That's how you learn in computer science. You have to be stuck and think hard, and then it comes to you, okay? But if you're stuck for too long, that's what I want you to do, okay? So I believe that is all of the administrative stuff that I wanted to talk about. We're still awake, I hope. We did it. So are there any questions about any of that while it's still fresh in your brain? You can, of course, ask me later, too. All right, so it is now time to take attendance. So the way that I've streamlined this for us is that I've made us a beautiful class website to go to. There's a link in a bunch of different places. The easiest place is on the home page of our Canvas site. Scroll down to the bottom. It is class website, but it's just www.lautensclass.com. I'll show that on a slide in a second. But one thing I do want to say is I have made you accounts in 2 separate places. Okay? The class website is one place. The class server, which I will show you later, is another place. I've made you 2 accounts. They both have the same username. All right? You changing the password here does not change the password here. That trips up a lot of people. I just want to say that. I had to make a slide for it. Okay? You have 2 separate passwords. They're 2 different places, but the username is the same. Okay? I hope that makes enough sense. So just telling you that now. So our class website is here. It's www.lautensclass.com, also at the bottom of our class website, or of our, what's it called, Canvas page. It will take you here. It will take you to the login page, first of all. And it'll be like, log in, please. And your username and your password are the same right now. What they are is your last name, no hyphens, all lowercase, no spaces either, and an underscore, and then a student ID. All right. So for example, if this is my last name. If this were my student ID, then this would be my username and my password right now on the class website. All right. If this is more like what your last name looks like, it's got some hyphens or even some spaces and accent marks. Get rid of them all, lowercase everything, and then plop your student ID at the end. Include the leading zeros. So this would be your username and your password right now. Okay? So try to get logged in. If you can do it quickly, change your password. It's probably easier that way. Change your password up here in the top right. And then you will see all these apps. And one of them is Take Attendance. And we'll go to that in a second. So I will come around and help anybody who's having trouble logging in. But this is how you do it. You should all have accounts, I hope. Is there anybody struggling? Because I can hopefully fix that. Yeah, I'll give you a minute, but we do all need to log in here because this is how I'm going to take attendance, and I have to drop you if you don't click the right button. So we have to be on here. So yeah, I'll just come around and stare at you. We'll go to the attendance place. I have to click start on my end. And has anybody else having trouble? The only thing I would think to try. Either that or more specific. Alright, anybody else having trouble? Alright, because I have to take attendance, and if you don't click that you're here, I will be dropping you. So just You have to tell me if you're struggling right now. So, all right, so you're going to go to this Take Attendance page, hopefully you're already there, and you'll click any of these. I don't even see which one. I don't save which one you click, whatever you're feeling for the day. But I'm going to do this on my end, and I'm going to start attendance for CSCI 40. I'm going to click Begin, and then you should be allowed to click. So please click a response, tell me that you're here, and then it'll all work. So you're only going to give us a few more minutes, so please let me know if you're having trouble right now. What's your password? All right, so show me how you're trying. No, that's your first name. That looks perfect. So you should be able to just copy and paste that. It should literally be your password. Anybody else? That one's going to be dropped. All right, and if you are as anxious as I am, you can go to the View Attendance page after you click it to just confirm that you're not going to be dropped. You can go back, be like, View My Attendance. It should be there, and a sigh of relief should appear.
Also, if I can have you guys move your backpacks out of the center aisle, that'd be awesome. So I can get through and help you guys. Really appreciate it. Thank you.
We've all said that we're here. Right? I'm about to stop now. Anybody who's not here, be dropped. Okay? Speak now. Going once. Going twice. Okay. Thank you. So that's how we're going to take attendance at the start of class from now on. It's much better than like me forcing you to pick a spot every day or like sending out a sign-in sheet. I'd rather do it this way. We're required to do it. Might as well make it easy. So that's that. Thank you. And let us begin with the real lecture time. Yay. Let's do it. So I would like to talk to you all about, let's see, a couple things. We're going to talk about computers in general, I guess, and then C++, which is the programming language that we will be learning in this class. Okay? So that is the plan, and I do just want to tell you that I'm going to throw a bunch of information right now into your brains. Don't feel like you need to understand all of it. You're going to eventually become fluent in computer science. Today, you are not a native speaker yet, right? So, yeah. I think one of the best ways to study all that we talk about in this class, because I'm going to give you all this code, just retype it. Retype it and try to understand every little piece. Okay. So that's that. Here are my goals. We don't have to look at those. But before we get started with the meat stuff, I do want to use this other page on the class website, which I am lovingly referring to as the ByClicker page. So I'm going to ask you guys a bunch of questions on the ByClicker app, and I'm going to do that in a second, just for fun. I like to ask you a little question called in-class exercises as part of a process called peer instruction. So I'm going to tell you to go and say hi to the people next to you, get into groups. Those are your peer instruction groups. And I'm going to give you a problem to think about and ponder. And that every single study that has been done about peer instruction just makes it very clear that you guys learn so much better from each other rather than by listening to me. So I promise if you don't like talking to other people, it is worth it just to get the extra knowledge, okay? So that's that, and I'm going to ask you a lot of questions using this ByClicker app, and the reason I call it that is because, I don't know if you've seen this before, but you will now, these are iClickers. If you have a large, science-y class, they usually use these. You got to pay $50 to press A through E, and I have made you a free version of that on our class website, so you're welcome. So that's what we're going to use And our first question, we don't have to get into groups for this one. We're just gonna I'm gonna ask some questions to figure out the makeup of the class. Some simple questions. And then, so yeah, that starts on the next slide. So get ready on the bike clicker page. It's gonna be our first in-class exercise, which people abbreviate to ICES. And our mascot here is a bowl that we named the Crush. And I do not understand why we did that. It does not make sense to me, but that's okay. So obviously, I will call our in-class exercises Crushed Ices. So, So now, here is our first question. So please go to the bike clicker page. I'll go to my end of it. And I will ask you a question that should be very easy for you to start off with. So let's figure out what the class is made up of. Who's here? What is your major? Please tell me. Is it something with computer in the name? Is it something with engineering in the name? Is it a STEM major? Or is it something else? Maybe you're thinking about switching. Or undeclared if we do that here. So yeah, I'll give you a few more seconds to do it. It looks like there's already 44 responses, so very good job, everybody. Yeah, who are we? That's an important question to ask, and we're going to know what our peers look like. So a decent chunk of us are computer science, which makes sense, but we have at least one person in every single category. Awesome. So I'm glad that you're all here because just the diversity makes it a better class. You're going to ask better questions, and you're going to teach each other in different ways, and I am very happy about that. So thank you. That was our first question of the day. So these are all just about how to figuring out the makeup of the class. Next is a kind of a knowledge-based question. So we're going to interact with the Linux terminal a lot. There's also the Unix terminal. It's pretty much the same thing. So have you ever used that before? What's your familiarity with it or your confidence levels on interacting with the terminal in a text-based LAN that looks like this? Whee! Again, this is your first computer science class, so it's okay if you press A. I expect a lot of us to be pressing A. All right, a few more seconds. All right, so yeah, a lot of us are A. Cool, somebody knows even more than I do, most likely. But yeah, a decent amount of us have even seen it before. So yeah, everybody who pressed B through E, please help the people who have pressed A. So that's something we're going to get into. I also, on the optional reading page on our Canvas, I put a little document that you can read and learn more about the terminal, because I don't have time to teach you every little thing about it. I don't even know every little thing about it. So there's that. And then, okay, final question. Have you ever programmed in C++ before? That is the language we will be teaching. We don't assume any prior knowledge of it, but let's see if anybody knows a little bit about it. Have you ever done it? Programmed in C++. Could you teach the class if I got sick one day? Nice. All right. A very, very skewed distribution. We've got a lot of us, no never. That's what I expect. But cool, a couple of us, 13 of us, have used C++ before. That's exciting. Again, everybody who picked these, help the people who picked A. Let's get us all up to speed. So yeah, thank you for humoring me with those answers. And we are ready for the lecture now. So again, shout out if you have any questions about things, but let's do it. So let's talk about computers, and then we'll talk about programming. So I guess just at a generic level, let's talk about programming first. So all a program is, it's nothing scary. It's just a recipe. If you've baked something before, if you've made something from a recipe online, you have followed a program, right? If you've modified a recipe, you have written a program. So that's the idea. Program is just a recipe. Another word that you'll hear a lot is the word algorithm. Again, it's not scary. It's just, all algorithm means it's a sequence of steps to solve a problem. Again, it's a recipe. So programs, algorithms, they're essentially hand in hand. And so the standard question that I like to ask every semester in my CSCI 40 classes is, all right, be a programmer for a second. somebody tell me, I got hit on the head and I can't remember how to make a peanut butter and jelly sandwich. How do you do it? What is the recipe for that? What's the program? Can anybody tell me? Yeah.
Usually you would start off by like cutting the bread up into slices, unless you buy sliced bread, and then you
Very
put
nice.
the peanut butter and the jelly on. Do halves of each half of the bread, and then you smash them together.
I appreciate the way that you're saying that because you're being more specific than the standard student, and I think you probably know why. So let me tell you probably what most of us thought. It's just like, all right, peanut butter and jelly is, you got bread, you put some peanut butter on it, put some jelly on it. Yeah? That's probably what we're all thinking. And let me pretend that I'm a computer running your program to make the peanut butter and jelly sandwich. You're like, all right, take some bread. All right, here is the bag of bread. This is my best 3D drawing of a bag of bread. Here are the little slices. All right, you get your bread, and then you put peanut butter on that, and you put jelly on that. So, all right, I, as a computer, I'm like, okay, here is the peanut butter jar. I'm going to put that on the bag of bread. And here is the jelly jar. I will also put that on the bag of bread. And voila, I have just run your program, made you a brand new, shiny, beautiful peanut butter and jelly sandwich. That's exactly what you wanted, right? Of course not. So the lesson here is one of computational thinking. So we have to essentially talk down to the computer when we write programs. The computer and processors and the programming language that we're learning, everything, it thinks at a level that is very specific. You cannot be general because it won't do what you want, all right? Just like this example. So you have to think at a very low level. You have to think in terms of little operations that the computer knows how to perform, and you know exactly what it's going to do, all right? So essentially the job of this class is me teaching you how to break problems down into little pieces that the computer can handle, and it'll do the right thing, the thing that you want done. And also there's a concept of like sequentiality, so like I want to do this thing before this thing before this thing, just like a recipe. So in essence, the correct program for a peanut butter and jelly sandwich would have been like, get out a plate, get out a knife, get the bread bag out, open up the bread bag, take 2 slices of bread, put one in each hand, slap them down on the plate, put the knife in your dominant hand, open up the peanut butter jar, dip the knife into the peanut butter jar, spread the peanut butter onto one slice, spread the jelly on the other slice, slap them together where the peanut butter and the jelly are touching each other, right? A lot of things could go wrong if you weren't exactly specific. Yes? That's what it means to write a program. That's all it is. You got to think at that level, and you'll be golden. Okay? So here's a silly little meme along those ideas that one of my students sent me once. So please look at that while I prepare for the next slide. Yes. Okay. So yeah, that's what computational thinking is about. That's essentially what you'll be learning. So here's all the little concepts that we're going to talk about in this class. So the algorithm, that's your recipe. It's essentially a program is made up of a bunch of little bite-sized things, little algorithms that come together. We also like to test things, right, in this class as we write our programs. We want to make sure they work. So the equivalent of testing in peanut butter and jelly land is like eating the sandwich. Does it taste good? Did we do it right? There's also the concept of assumptions, where those are like, all right, what do we really need? You have to think about that. What is not listed, but we really still need it? What's required in the solution, but not mentioned in the problem? So, for example, like if you want to light a birthday candle and it's your birthday, and you have some weird aquatic-themed birthday party, you cannot sue the manufacturer for trying to light the candle underwater and having it not work, right? The assumption is you're going to light the candle in like a room where there is not a lot of wind and there's also not water on top of the candle. Okay, so those are assumptions that you'll have to think about, because sometimes, like, I can't tell you exactly what to do. You'll have to think. That's part of the process of learning computer science. And then finally, just that term computational thinking. If you want to see that spelled out, what that really means is like thinking sequentially, thinking clearly, thinking at the right level of abstraction. So at the level that the computer can understand and follow your instructions correctly. And so put a little star next to this, because that is our goal. If I can do anything, I want to teach you this. Right? That's the goal of the class. So that's that. Again, yell at me if you have any questions about anything. let's keep on trucking. So let's learn about pieces of a computer in case we've never heard of them before. Like here's a nice little model of a computer, at least at the level that I want you to think about it for the first part of the semester. So you've got a few bits and pieces that make up a computer, right? You have your input devices, ways to give information to the computer. So keyboards are a good way to give information to a computer. Clicking on a mouse, tapping on a touch screen, those are input devices, right? Next, there are output devices. Like those are ways of getting information from a computer. So you got your screen, you're looking at the output on your Windows, you can print stuff. That's another way of getting output. Things like that. Those are output devices. Next comes the processor, or CPU. That stands for Central Processing Unit, right? The metaphor is that's the brain of the computer. That's where it's doing the thinking. That's where it's running your program. And another word for that is executing your program. It's not like murdering it. It just means to run it, okay? So that's all working. That's like the main piece. The processor's working hard on stuff. Very important. That's where all of our code is getting run. And then there's main memory, or RAM. That stands for random access memory. That's working together with the CPU in tandem. Those are the two most important pieces that I care about you understanding. What RAM is, what memory is it stores information, just like holding on to stuff. It's memory. It's storing information about the programs that are currently running on your computer. So when you double-click something and you load a program into your computer, every program gets copied into memory, into main memory, before it gets run. And so that's why if you want to have a bunch of tabs open, you want to run a bunch of programs at once, and you want it to work, then you have to have a lot of RAM on your computer. So this is a very fast thing to access. There are places that we store things that are not RAM, right? That's your secondary memory. That's like your hard drive. There's a lot more room there, but it's slower to access. So we want to bring it into the RAM when we run something. Things like that, things like little flash thumb drives, stuff like that. Those hold a lot of information, SSDs, but they're slower in general to access than main memory. So that's why we move everything there before we have all that be used to interact with the CPU. Okay, so those are just pieces of a computer. Hopefully we've at least heard of these terms before. I'm not going to test you on it. This isn't a hardware class. This is a software class. So that's all that I really care about you knowing. The next major piece is C++. So that's going to be what we learn in this class. That's the programming language. That's the window into computer science that I'm giving you, right? We're going to learn C++ as our first programming language. And it was invented back in 1985, so it's been around for a while. It was invented by a nice Danish man named Bjarne Stroustrup, I think is how you pronounce his name. And it's based on a language called C, and so they put a plus plus at the end. There's a joke there that I'll get to teach you in a second. Maybe not today, but maybe next time. But it was based on an older language called C. It's like the next better one. And it is called a high-level language. So even though it might not look very much like English to you, trust me, it looks a whole lot more like English than the ones and zeros that a computer really understands and executes, right? So that's why we call it a high-level language. It looks like English rather than binary. And it's also a compiled language because we're writing essentially English. Like our programs that we write essentially look like English, like the blah, blah, blah. Pretty much just text. A computer can't run that yet. We need to get it into a form that it can run, and we use what's called a compiler with C++. It's a compiled language, which means we have to bring in another program that somebody else already wrote called a compiler. We shove the program into that, and then out plops the ones and zeros that the CPU can actually run. So that's what it means to be a compiled language. And I guess we're ready. Drumroll please, I guess. Are we ready to see our first simple computer science program, our first C++ program that is complete and runs? It is, the simplest program is one that does absolutely nothing. So we're not going to learn much from it, but let me at least show it to you, and then I'll explain more to you later. So here I am on the terminal. I'm going to make a new program in my editor, and I will call it do nothing. And the standard extension for C++ programs is .cpp. So I'm going to make a file called that. And here is C++, the simplest program that does nothing. I say int main, 2 parentheses, some curly braces, and then I say return 0 and a semicolon. Trust me, you'll get used to this. But that's the simplest possible C++ program. Let me run it for you. Let me compile it for you. The compiler is called G++. So I'm going to give the file to that. And if I press enter, it makes a brand new file called, here's my old file, and here is a.out. If you don't give it a name, it calls it a.out as its final executable program. And then to run it on the terminal, I say /a.out, and I hit enter, and it just gave me my terminal prompt again. It did nothing, but it ran. Yay. So that's the simplest possible C++ program. Doesn't really teach you anything. I'll explain this with a better program in just a second. Okay. But before we get there, I want to show you more about the terminal because we're gonna be using a lot. So let's see here. I guess let's do it like this. I'm supposed to be doing this. God, that's ugly, but that's okay. Okay. So here's my terminal prompt. It's way over here now for a reason. Sorry, but it's like this is where I type this part. Everything else is called the prompt. It's just showing me information about what's going on. And let me show you some stuff about the terminal. So when you log in on the class server, it's going to take you to a certain place called your home folder, and that's going to be referenced by the tilde. Okay? And so that's called your home folder. It's a special folder with just your username. You can use, oh gosh, I don't want to get ahead of myself. So tilde is your home folder. If you're there, like once you're there, there's always a concept of the folder you're working in. And so you're currently working in your home folder once you log in on the class website. It's a folder just for you with your username. If you want to see what's there from the terminal, you say ls. It stands for list. It shows you what is in your current working directory, we say. It's the directory you're currently inside, the folder you're currently inside. And so apparently, I have all these different little folders, no files, but just folders, on inside of my home folder. Got desktop, documents, downloads. Yours is going to be empty when you log in first on the class server. But that's what it looks like. ls shows you what's there. If you ever get lost and you're wondering, like, where am I? PWD is short for print working directory. It shows you where you are if tilde is unhelpful. If like you're in your music folder or something, like where really am I? Okay, I'm inside of the root directory. There's a home folder inside of that, and then inside of that there's a folder with my username, and then inside of that there's a music folder. That's where I am right now. Okay, that's how you move around. If you want to go places, you use the cd command. That's called change directory. That changes directory is another word for folder. It changes you to be inside of. Your new working directory is that folder's name. Okay? That's that one. It's like there's a music folder. I don't think there's anything inside of that. But if I want to go back to my home folder, it's always cd tilde. It's always a shortcut for my home folder. ls to show what's there. Maybe I want to go in the videos folder. I don't know. Sorry. And then I'm inside of that now. Print working directory. I can see where I am. A shortcut to go back out, like to the directory I came from, it's called your parent directory. The dot is short for that. Dot is short for your parent's directory, so the one you just came from, cd dot. So I'm in home lot videos, cd dot takes me just to home lot, back to my home folder. Okay. You will do this so often that these will all become second nature, but you can look at this table when I give it to you. To compile a program, we use the G++ command. That is it stands for the GNU C++ compiler. Those are the people who were nice enough to make the compiler for us. You just say the compiler, and then you space separate and give the name of the program that you would like to compile, just like I did. Let's go back to Let's go back to where I was. I think it was Windows Desktop. You can go multiple places at once inside of folders. F23, 40, CSCI 40, lecture 01. Okay, that's where I was. And I have all these files. And so I compile do nothing.cpp by saying g++ do nothing.cpp. And I'm sorry, it's spilling onto the other part because I made the font size so large. But I'll just come back to this. Let me make it smaller again. There. So I said g++ do nothing.cpp. And that created, if it worked, the a.out file, which I can go and run with saying the name and just putting a dot and a / in front of that. Dot, by the way, stands for your current directory. Dot stands for your parent. So it's like, in my current directory, please run the thing called a.out. That's what it's saying. Okay? So that's that. And I think that is everything that I wanted to say about all that. / stands for, hey, please run this thing in my current directory. Okay? So I'll give you this slide, and you can look at it. But that's essentially how you move around on the terminal. Okay? The next major piece is writing code from the terminal. right? There's a bunch of different things called editors, which are just programs where you can edit files and change them. The editors can be terminal-based, like the one that I was using. They could also be graphical. Technically, Microsoft Word is an editor. Yeah, there's more. The easiest terminal editor is called Nano, and you can start with that one, but I really want to get you learning the good one, which I'll talk about next. But to use Nano, you can say just the name, Nano, space, the name of the thing, the name of the file you would like to edit. So you can give one that already exists, or you can give one that doesn't exist yet, and when you save it, it will. You hit enter, and it plops you into Nano. This is an editor. You can move around with your arrow keys, and you can type stuff. You can change the file. And then when you're done, all these things on the bottom are telling you how to use Nano. So like the caret means control, so control G for help. Control X is what you want to get back to the terminal. It saves and quits Nano. So control X is what I'll type. Do I want to save what I just did? Y for yes. What file do I want to call my changes? It doesn't have to be the original one, but I want it to be the original one, so I'll just keep it as it is. Hit enter. And now that takes me back to my terminal. And if the file didn't exist, now it does, or if you changed it, it got updated. Okay, that's how you use Nano. I have been using an editor called Vim instead. And so, let's see. It works exactly the same as Nano. It just has some cooler stuff inside of it. And I want you to do a tutorial before you try it because the meme is that nobody knows how to quit out of Vim. And I'll show you how to do that later. But this is another editor. Notice that there's line numbers. It's cooler. I can copy and paste so easily. It's good to learn. I'll get you doing a tutorial by the end of today. But that's another editor. That's the one I like to use. There are other graphical editors that people like to use. Visual Studio Code is probably the most popular graphical editor these days. And if you want to work on your own computer, I can help you set it up. Then you can just transfer files between the server and your computer as necessary. So that's the terminal in a nutshell. I'm going to give you another introduction to that during our lab time today. So you can ask me questions then. Let's see, what else? Let me try and motivate. Like, why in the world are we teaching you C++? There are other languages out there. Why this one? So one very good reason why we're learning C++ in this class as our first language is it's on the lower side of the high-level languages, about as low as you could be and still teach somebody for the first time. If that makes any sense at all, it's closer to the CPU than some other languages like maybe Python that you've heard of, like Java. So it's better because I'm forcing you to learn a bit more about the computer that way. And you'll write better programs because of that. It's also very fast because it's closer to the middle. And everybody's using C++. If you write, all of the Adobe suite isn't written in C++ because they need speed. Every web browser, the back-end engine of that's like rendering your pages, is written in C++. Pretty much every game that's being developed that is computationally intensive is using C++. Okay, so it's a popular one, and hopefully you enjoy it. And once you learn one, you can learn the others, so it's not really a big deal anyway. I think it's a good choice. So, all right, with that in mind, let me tell you a little bit more about compilers and compilation. So what a compiler does, again, is it takes your code and it translates it into something that the computer can run. Let me be a bit more specific, though. The technical terms for all that is like machine code or object code. So technically, the compiler, like, here's your C++ program, do nothing.cpp. You give that to the compiler, and what it's doing, it's unfortunate because G++ is doing the job of a lot of different things, but technically the word compilation means generate from a single program file, a single .cpp file, object code or machine code. So for a split second, it makes like a .o file. That's what .o stands for, object code. And you make a bunch of those for every file that you write. And then the next job is separate. It's called linking. There's another program. Unfortunately, G++ does both, so it's hard to explain right now. But the linker is a separate piece that combines programs. Because usually you write a bunch of files and you bring them together, right? A linker combines your programs together so that they can all exist and run, so that it knows where everything is. A lot of the time, even if you're writing a single file, you're using code that somebody else wrote. You're using what are called libraries. We're going to use a library called IOStream in just a second. That's going to let us print stuff to the terminal. We would like that. We don't want to have to reinvent the wheel, and so that's going to give us access to things called the terminal screen is, you can get that through standard : cout, which I'll show you in just a second. And so stuff like that, you want to bring into your program, and so you link that. That's what that means. And so a library is just like, that's what the metaphor means. It's like somebody else wrote a book, I'm using that book. Somebody else wrote code, I'm using that code. So yeah, after those two processes are completed, you then have, G++ does both for us. You then have a final executable file that you can then go and run that gives you your a.out. If I can write a U, and then you can run that with your /. All right, that is, I don't expect you to memorize this or anything. I'm not going to test you on this right now, but that's what's going on under the hood, right? And that finally gives us something we can run. And now I'm ready to finally teach you some real C++ and explain to you what in the world was going on before, right? So they would take my computer science degree away if I didn't do this. The very first program you're always supposed to write when you learn a new language is called the Hello World program. You write a program, and what it does is it prints Hello World to the screen. So for some reason, that's what you're supposed to do, just to show that you're the master of the language or something, and you can have it do your bidding and like do whatever you want. So that is that. And so let me make a program for you that prints Hello World to the screen. Yay, it's going to look a lot better than do nothing. So I'm going to edit a new file. I'm going to call it hello.cpp. We're going to get the idea in just a second. But I would like to print stuff to the screen. We're going to have what we had before. Int main, brackets, return 0. We're going to have even more than that. At the tippy top, I'm going to include the IOStream library. And then inside of the curly braces for main, I'm going to use the access that I have to the terminal screen through standard : cout. I want to shove information into it, which is why I use the two less than signs like an arrow. I want to shove this into it. I want to say hello, comma, space, world, exclamation point, semicolon. Okay? And so that is a program. I can compile that. I can run that. Let's see, how do I want to do that first? G++. Oh, gosh. There's a way I want to do this, and it's not the best way. Let me do something very silly. Give me a second. Export PS1 equals something like that. Yeah, okay, cool. So here's my terminal prompt. I've made it very, very small now. It still works, though. ls does everything. Let me compile. G++, hello.cpp. So that rewrites the a.out file. /a.out. Enter. Look at what it did. It printed hello world, exclamation point, and then my terminal prompt started on the same line again. That's kind of ugly. We'll fix that in a second. But that was our first program. Yay. Let me explain what just happened. All right. So, okay. The first thing I want to do is tell you how you can write English inside of your programs. Those are called comments. Just for you, not part of the compilation process. If you start a line with 2 slashes, that's a note just for you, the programmer. Write as many as you like to remind yourself what you were doing. It's very important. So I'll be like, we can compile this with G++ hello.cpp. That's like a little note for myself. That's a comment. Everything after the 2 slashes, the rest of that line is a comment. Right? That's called a single line comment. This is a single line comment. I guess this is a new term. So comment in quotes. It's meant for programmers only. It's not code. If I want to comment on the next line, I need 2 slashes again. It's not code. If you want to more easily write a bunch of lines and have them all be comments, you can use a /* and a / to just separate them all. So this is a multi-line comment. Yay. And then you end it with the */. So that's how you can write notes to yourself. And so now I can explain everything by writing comments next to it. So what this line does, what include IOStream does, is it includes that library that gives us access to. This gives us access to standard cout. It also gives us access to other stuff inside of IOStream. There's another one that we'll use, standard endl, in a second. That's that one. Let's see. And then we have this weird thing. What does int main mean? So again, I'm going to use terms that you don't know about yet, but you eventually will. All right? But I'm going to say them so often that you'll eventually understand what they mean before I tell you exactly what they are. So what this first line is saying is it's creating what's called the main function. This is called the main function. It's where the program starts. It starts running code inside of these curly braces. That's where it begins. It's where the program starts. All right? And so standard : cout is, like the first line of code is sending information to cout with these two arrows, sending the words hello world into cout, which is the terminal screen. So standard colon cout is the terminal screen. And everything between double quotes is called a string. We just wanted to call it that instead of like a quote or something. Things between double quotes are called strings. Think of it like strings, and like the letters are little beads on a friendship bracelet that you're taking to the Taylor Swift concert or something. That is why we're calling it that, apparently. So that's that. Strings. And then return 0 needs to always be there. This is what marks the end of the program. This is when we say we're done, right? So marks the end of the program, tells the terminal that your program executed successfully or correctly. 0 means we did a good job. Anything other than 0 tells the terminal we messed up somehow. So 0 means success. That's why that works like that. You also see semicolons after both of these lines. Semicolon is the period to C++. So semicolon marks the end of a C++ what's called statement. Each line is a statement. It's the equivalent of the English period. It's like, I'm done with that thought. Okay? So that is our complete Hello World program commented out. Does that make anything easier to understand? Any questions about that so far? Just be a sponge, soak it all in for now. So one thing I do want to tell you is this was ugly when we ran it, and it was like print hello world, and then the terminal prompt appeared on that same line. We don't like that. So you can give special characters in a string. They start with backslashes. They're called escaped characters, and those allow you to do cool stuff like press enter as you're printing stuff. There's no way otherwise to do it. So you say \n stands for new line. I would like you to print a new line, please. So I'll add that to my string. You can't just like press enter and have it work because there's spaces here. It's not right. So \n just stands for new line. Right? It makes a brand new line. And look at how it's going to change when I run the program now. Recompile with G++, rerun with /. Now it says hello world exclamation point, and it breaks that line. Now the prompt happens on the next line. That's how it should be, right? That's cleaner. Much better. So that's that. What else? There are other escape characters like \t stands for tab. \r, I'll let you discover what that means on your own. I'll tell you about it later in the class. But the / is overloaded. It's like it's expecting something else. So if you want to type a single \, you really have to type 2. It's like escape the \. That's what it's called. So that will give you a single \ printed. It'll take some getting used to. But yeah, \n is nice. What else? Instead of \n, you could also use standard endl. That's just a little piece of the standard library that also exists. You can give multiple things to be printed. Be like, print this, and then just give more arrows. And then also print standard endl. That's just short for in a certain way. It's more typing, but I promise sometimes it's useful to say endl instead of \n. Again, that stands for the new line. It does the same thing. All right. This is a lot of typing now. So one thing we would like to do is make it a bit shorter. Wouldn't it be nice if we could just like skip the standard : It's like, I just want to use cout. I just want to use endl. Let's call it that. There's a way to do that. If at the start of your program you say using namespace standard and a semicolon, you say this. Usually here is where I do it. Using namespace standard, semicolon. This is essentially the one line by itself that doesn't have a semicolon for a weird reason. But this line says, all right, I can skip. I'd like to skip using. I'd like to, now, or how about I say it like this? Now I can skip the standard : What this is saying is, all right, if I use something and you can't find it, just look here. That's where it's going to be. So now I can get rid of standard : everywhere. I can just say cout, I can just say endl, and it really does become shorter sometimes. Exactly same program, okay? So that's that. Any questions about this so far? We're adding to this, that's for sure. That's the program. The curly braces mark the beginning and the end of this program. That's where it begins. That's the main function. Let's see here. Strings we talked about. Escape characters, that's what the \n is. It's an escape character. It stands for the new line is going to get replaced with that somebody pressing enter on the terminal for you. So there's that one. Yeah. So yeah, that standard : just use that thing from the standard library called that. So that's the first program I wanted to show you. Let's do another one that does some math, because computers were made to do math, right? Let's do some of that too. So I'll make a new file called let's do an area program. Let's write a program that prints out the area of a circle with radius 5. Why not? All right, so area.cdp. So again, include IOStream, using name, space, standard, int main, 2 parentheses, open curly quotes. Don't forget to return 0 at the very end to mark the end of the program. And then above that is whatever you want done. So I'd like to print, please. Now I can just say cout. I'd like to print the area of a circle with radius 5, and that's pi r squared, so 3.14. And then multiplication in C++ is the star, so times 5. There's not a very easy to the power of operator, so I'm just going to say 5 times 5, or 5 squared. And then a new line after that. So please figure out what this is, solve it, print it. You're sending it, you're shoving it into cout, the terminal screen, and then also send a new line after that. All right, so to compile, g++ area.cpp /area, it's getting replaced with that. And apparently, with that approximation of pi, we get 78.5. So it did math for us. That's the reason we have computers today, so we can do stuff like that, I guess. That's what people really originally wanted. So that's that. One thing I do want to tell you is C++, because you're using semicolons to mark the ends of your thoughts and things, the white space, the space around everything, is part of your lines. It doesn't matter at all. So technically, you could have your entire program on one line. You could do weird stuff like this. C++ does not care. But hopefully you understand that this is ugly and the way that I do it is pretty. This will compile and run. I just want to be clear. We don't want this. It's hard to read, hard to understand. So I'm going to try and show you the best practices, but honestly, it's up to you. So that's how that works. And that's also a reason why I'm indenting here. It looks better. That's just things that people have customarily started doing. So that's white space. It doesn't matter, and people have different preferences, but just try to make it look clean. Shouldn't be a problem. I think your book types things slightly differently than I do, so you'll get a flavor for everything. But yeah, we just wrote some programs. We ran them. You should give yourself a pat on the back. You did things, and you understand them a little bit, right? You'll learn more, but that's the start of it all. Yay. So, all right, let's keep on trucking. I have a few last things before the end of the lecture, and then we'll have a little break, and we'll come back, connect to the class server. But I want to show you a few extra things just to get us ready for next time. Some concepts are variables, types, and input. All right, so let's start with variables. A variable is just some place where you store something. I'll draw it as a box. It's just a place in memory. Just think of it as a box in memory. And so this line is saying, please make a box called X, and we'll have it hold 42. That's what the line is saying. I'll tell you what the int means just now. The int is a type, right? The int is saying the thing that I'm putting in X is an integer. It's a whole number. So you specify. Types are very important in C++. And so here are a few types, and I'll teach them to you. So think of types like clouds. That's what I think of them as. So what lives in the int cloud? What are things that can be ints? Those are only whole numbers. So like 0, 42, the number 8. Negative numbers too, so like negative 42. Those can all be integers. Those are whole numbers. So you'd make a variable that's of type int to hold those whole numbers. If, however, you wanted to store pi or something, wanted to calculate areas, you need to use a different type, one that can handle non-whole numbers, numbers with decimal places. That's called double. Those hold decimal numbers. So the double cloud could hold things like 3.14. It also holds whole numbers, you can do 12.0, but there's the idea that it could hold the decimals as well, if you wanted it to. It's rounded or something. So that's what double means. There's a reason it's called double. I think your book is going to explain that. there's like a single something. This is double that. And then there is, if you want to store a single character, that is called, I call it char. Some professors say care. I learned it char, so who cares? Say what you want. But if you want to store a single character, that lives in the char type, and you make those with single quotes in C++. Like single quote A, single quote space. You want to store a single character, not a bunch, just a single one. You use a single quote, and then that character. That's the char type. Then we have the string type, which you know already. That's stuff in between double quotes. That has type string. So like quotes, hello, double quotes. Double quotes, a number is a string, not the number, right? It's different type. String the, you can have spaces. We had our hello world, of course. You can have escape characters. And so those are a bunch of variables. Let me show you a program just using those, printing them out. So vars.cpp, I'll call it. And again, include IOStream. You're going to get used to this. Using namespace, standard, int main, return 0 at the end. Okay, now we can do what we wanted to do. I want to make, let's hold an integer. Let's make an integer variable. Call it x. This makes an integer variable, and it holds the number 42. And now the whole point of a variable is that you can say x rather than 42 everywhere. Like cout whatever is an x. Yeah. So if I compile and run this, to vars./a.out, I get my 42. Cool. Instead of saying 42, I can say x. Same for the other types. So double was decimal numbers. So let's make a double called d. These names can be anything, by the way. Just you can't really have spaces. They could be as long as you want. I'm just going to use single characters. So cout d. What's in d? I'll print the 3.14. Let's do the rest. So char. Let's make a character variable. Call it c. Have it hold capital A. Single quotes. And then we'll print that out. Print out whatever is in c. And then a new line. So these all appear. They will all appear on separate lines. That's why I'm doing it like that. And then the string type is special. To use the string type, you have to include the string library. That gives us access to the type. Have to include the string library to use the string type. So now I can make a variable of type string. String s equals hello. Cout s. So here's the program. Let's recompile it, rerun it. That's like, all right, x holds 42, print the 42, 3.14, capital A, hello. They're all on new lines. And then my prompt appears all after that. Right? So these are the meat of the program. This is the lines that I care about, you understanding. Are there any questions about that? Just the variable is a place in memory where you can store stuff. You can call it with that name after that. That's very useful, I think. Let's see, what else? So I've shown you how to give stuff back to the user, like you're printing to their screen. If you want to get stuff from the user, like have them type something for you so you can put it into a variable. The opposite of cout is cin. So let me show you that. That gets input from the user and it stores it into a variable. All right, so let me show you a program for that. I'll edit a new file called cin.cpp. And I'm just going to copy and paste that scaffolding. You know it now. So, okay. Let us ask the user for something, and we're going to store that something that they type into a variable. So I need a variable to begin with. So let's make that variable. I'll just say, let's put it in a variable called x that holds a whole number. We'll ask the user to type a number. So I can say int x semicolon if I don't have something to put in x right now. The user is going to give me that thing. So this makes the variable but doesn't give it anything. X holds essentially nothing right now. I'm going to fill it in just a second. I'll fill it with whatever the user types through the cin command that I'm about to use. Okay? So let's be nice to the user. Let's tell them what we want. So let's say cout first. Let's print, hey, user, enter an int. Colon space, semicolon. I'm not going to break the line right now, and you're going to see why. Because it's going to print this, and then it's going to wait on that same line for the user to type. It looks so nice. All right? So I'm not going to break the line here. And then I'm going to say cin and x. And I have to use some arrows here. In which direction is information flowing? Are we shoving information to the screen? information going? If CN is the user's keyboard.
Go.
It's going index. So it better be the other way. See that? That's how you do it. And so the user is going to type the number, and then they're going to hit enter. And so that's going to break the line for you anyway. And so it'll get that number, put it into X, and then we can just be like, hey, you typed this. You typed, and then a space, then the number, and then a new line. Something like that. Something simple.
And,
yes?
the program will wait until you type something into X.
That's exactly right. So watch. Let me run. So I just compiled it. ./a.out. Enter an int, space, same line. Cursor's waiting right there. Isn't that cool? So then I can type as the user something. I just typed that, and I hit enter. Then it gets it. Then CN gets it, and it set the variable to whatever I put there. And now we can extract that number by couting it. Isn't that nice?
What if you were to type something other than it?
That's a great question. So it's going to do its best effort as figuring out how to convert what you just typed to an integer, but it's not going to be ever what you wanted. I think just characters by itself is going to be 0, because like I didn't find a number. The default number is 0. Something like that. Yeah, good question. So you can get whatever type you want from the user, but you have to specify. And that's how CN knows what to get. So if I want to get a character, I'm going to give a character to CN, or try to fill one from CN. So like cout, enter a char. Now I can use CN into C, and that's how it knows to get it as a character. Right? The types are important. Double D. If I want to get something with with decimal places, enter a double. CND. So I'll get both of those, and I can print them out. Cout C on its own line, cout D on its own line. Recompile, rerun. So 42, enter a character, I don't know, L, my initial, enter a double, 3.14. So it stores them all. It's like, all right, that's going into C, that's going into D, and we can get them back. We can use them in a bigger context to do math with them, stuff like that. All right, so that's CN, opposite of cout. It's filling in a variable. Any questions about that? That's very useful. Usually you want your program to run differently depending on what the user gives you. So that's that. And I think, I'm excited. We're going to try some stuff now. Now I have some questions for you guys. So in the last few minutes of the lecture part of this class, please go to ByClicker, and you guys can get into peer instruction groups as well. So just say hi to the people next to you, introduce yourself, and once you've done that, please answer this question. See if you can convince your neighbors that your answer is right. What does a compiler do? Were we awake when I went over that? I'll give you a minute.
I think it's
Never know. Another 30 seconds or so. All right, let me bring you all back. I'll get you right back into groups, I promise, in just a second to answer one last question. But let's go over this one, and then I'll put you right back. You can hang out some more. Nice. We're thinking C. All right, and C is in fact the right answer. So a compiler, its job is to take your English-looking code and translate it into that A.out, that thing that the compiler can, that your CPU can understand and run. Good. Yes. So it's essentially the terminal that's running the program, more or less, the operating system. And let's see, stores your program when it's run. I don't even know if that makes sense, honestly. Maybe your memory, I guess. That's what I'm trying to mention there. That would be your main memory. Yeah, that is logical. Never mind. But yeah, C is the right answer. Definitely not D. Okay, so good. One last question, and oh man, I rewrote this class website over the summer, by the way. We're going to see right now if it can handle what we're about to do. Please try going to the written ice page. I'm very excited. I don't think there's anything, but I'm going to clear it out anyway. So it'll take you here, and you can edit and create a post here, and you click submit, and that'll take you to the view all post page. You can also go back and change it later if you want to change your answer. But this is how I'm going to get you all to show me your answer that's not just A through E. Okay, I wrote this. I'm very proud of it. We're going to see if it can handle all of us connected at once, though. So, yeah. As a group, please just write both answers, I guess. What in the world is the terminal command, the first one, to compile a file if it's called x.cpp? How do you compile it? What do you do? And then what is the command to run that compiled program after you've compiled it? So write both of those answers, see if you remember. On that written nice page, I'll give you a minute or so. Discuss.
Are we looking for the command or what? Just what the command is, or are we looking for like the whole line that you're going to type out?
No, what on the terminal would you type? And then hit enter and it would do that thing. It was fast, right? I did it a bunch of times, but it was still fast.
It was B++. The word compile I think it's just I think it runs.
All right, I'll give you 30 more seconds. I think you can cheat and see other people's answers by now. I hope.
Okay, so the terminal command file is G++, probably something or other, and then the file name. But the command to run that compiled program would be
All right, let me bring us back one last time. We're almost ready for our break. Let's do it. So, very nice. A lot of us are getting it. Very, very nice. So, group 4, almost perfect. Let's see here. Who's got it exact? Let's see. Oh, yeah. Group 18. Good job. Group 20. You guys, awesome. So, to compile a file, we use G++. That's the name of the compiler. Then you give the name of the file. You can do more, actually. And I'll show you that in the lab section time. That's going to create that A.out file. And so if you want to run it on the terminal, you say /A.out. So those are the two answers. Any questions about that? You'll get so much experience with that it will become second nature, I promise. Okay? We good? Yeah.
You put it on the same line.
You have to say this and press enter for it to create the A.out file. Yeah. All right. So my last thing I like to do on the first day of my CSCI 40 class, you're in for a treat. I like to make a program with everything that we know, and it's actually kind of useful and cool. So I've made a silly little karaoke program that I've written and I've extracted from something. But we're going to have the computer sing to us now, through text, of course. It's going to sing the words to a song that I think most of us are going to know. So Frozen's Let It Go, obviously. And it's a cool demo just showing you what you can do with just printing. All right. So I am going to have to stop the recording because sound is going to come out and they're going to like give me a copyright strike on my YouTube channel if I keep recording this. So we're going to stop in just a second. So sadly you had to be here to hear it. But that's going to lead us into our break. So here is a program called karaoke.cpp. Relax, you don't have to understand all this. This extra stuff creates what's called a brand new function. I'm calling it pause, and it's stopping the program for a certain number of seconds. So it's like pause for 3.1 seconds and then continue. But the rest of this is stuff that you know. So all this program is cout, printing stuff, and then waiting with this pause function that I made for myself. Right? You could do both of these. Print stuff, stop. Print stuff, stop. And this, if you get the numbers right, will sing Let It Go to you. Woohoo! We know all of this. It's just printing. Printing and pausing, printing and pausing. So I encourage you to play this yourself when you get home. You can play on the class server. But I'm going to compile this. And for fun, I'm going to show you how to compile in a better way. If you say G++, that thing, and it's going to make that a.out file, normally we don't want to make the a.out file. We want to call it something normal. If you say -o, then the name of the program, like whatever you want it to really be called instead of a.out, then you hit enter, then it's going to call it that thing. So I just want it to be called karaoke without any extensions. And so now instead of overwriting a.out, it made this brand new thing that was the compiled form. Okay, so that's how that's working. Let me do my best at getting this all on the same screen. I'm going to stop the recording now so that my